Today in physics, we will be learning momentum. My name is Anthony.
My name is Terry.
My name is Vicky.
And I'm Nico. The car that just went by is an example of an object that has momentum. Why? Because the car had mass and the car had velocity. Therefore, momentum is mass times velocity. In this equation, P represents momentum, M represents mass, V represents velocity. The arrows on top of P and V mean that momentum and velocity are vector quantities, and this means that direction matters. As you know, the units for mass is kilograms, and the units for velocity is meters per second. Therefore, the units for momentum, which is mass times velocity, is kilograms times meters per second. As an example, let's find the momentum of a rolling ball. The ball that we will be using has a mass of 4.0 kg. Let's assume that it rolls at a constant velocity of 2 meters per second.
Now let's plug in the equation P equals mv. P equals 4.0 kilograms times 2.0 meters per second. Therefore, the momentum is 8.0 kilogram times meters per second.
A force applied over a short period of time is called an impulse. Now, the formula for an impulse is force multiplied by the change of time.
This is a good example of force times change of time equals impulse.
In this example, Anthony will shoot the ball with a force of 150 newtons. Delta T is the amount of time Anthony applies the force onto the ball, which is usually a short amount of time. For example, the time Anthony applies the force is 0.10 seconds. Therefore, after plugging in these numbers, the answer you get is 15 Newton seconds.
The law of conservation of momentum states the momentum, which is P, of objects in a closed, isolated system is conserved. Therefore, the total amount of momentum does not change. Momentum is the same before as it is after. Momentum is conserved.
When an object collides with another object and sticks together, the formula is mass and velocity of the first object plus mass and velocity of the second object equals the total mass times the total velocity.
The mass of object 1 is 6 kilograms, and the velocity is 4 meters per second, plus the mass of object 2, which is 45 kilograms, and its velocity is 0 meters per second, which then equals the total mass, which is 51 kilograms, and its final velocity. The total velocity after would therefore be 0.47 meters per second.
So the first collision is an elastic collision. This is what happens during an elastic collision.
Car A and car B initially collide, moving towards each other. The cars rebound in the opposite direction, and the momentum of the system is conserved. Therefore, the formula for an elastic collision is momentum of A initial plus momentum of B initial equals momentum of A final plus momentum of B final. In other words, momentum is conserved.
Now let's look at another example using balls.
A 0.25 kilograms ball is traveling to the left at a velocity of 4.5 meters per second when it collides head-on with the 0.30 kilogram ball traveling right at the velocity of 5.0 meters per second. After colliding, the 0.25 kilogram ball is traveling right at a velocity of 2 meters per second. Find the velocity of the 0.30 kilogram ball after the collision. To find the velocity of the 0.30 kilogram ball, we will use the elastic formula, which is mass times velocity of object A initial plus mass times velocity of object B initial equals mass times velocity of object A final plus mass times velocity of object B final, which equals negative 0.42 meters per second.